Hello everyone, in this video we'll be solving problem 189 rotate array. The problem statement is given an integer array nums, rotate the array to the right by k steps where k is the non-negative number. In example number 1 with numbers starting from 1 all the way to 7 and k is 3. In the output all of the elements are shifted by 3 positions. So one that was occurring at index 0 is now occurring at index 3. And all of the elements that would have spilled over after shifting all of the elements by 3 needs to be appended to the start of the nums array. So the numbers 5, 6, 7 have been moved to the start. Similarly, in example number 2, the value of k is 2. So the last 2 digits were shifted to the start while the first 2 digits are shifted to the right by 2. I hope you were able to understand the problem statement. This problem can be solved using multiple approaches. We'll start by discussing the basic approach which consumes O of n space complexity and then optimize it to use constant memory space. Let's switch to whiteboard and discuss those solutions. The simplest approach requires the use of an additional array or a collection which will be used to save all of these values in the shifted form. That is, each of these numbers will be shifted to its right by k values and saved it in this result variable. Let's run a couple of simulations to understand this better. Starting with I is equal to 0, as we are shifting the elements by k position, the new position will be I plus k, which will be 2. We'll repeat the same operation for the next element, that is the value at index 1 and then index 2. So results array will be updated with 1, 2 and 3 at position 2, 3 and 4. When we are at index is equal to 3, we are looking at this number 4, and if we apply the formula of I plus k, the result is greater than the size of the nums array, which will cause index out of bounds exceptions. To avoid that exception, we will apply the mod operation using the size of the inputs array. So after applying this formula, we'll get the output as 0, and this is where we'll save the number 4 at. For the next run, we'll increment our I to 4. So I plus k will give us the value 1 after applying the mod operation. So I'll save number 5 to position 1. And once the iteration is done, we'll replace this result into the nums array as the problem statement is asking us to do an in-place operation and return it. With this solution, our time complexity is O of n as we are iterating through the nums array once, while the space complexity is also O of n as we are using this new array to store the values after shifting it to the right. This is one way of solving this problem. Now let's discuss how we can improve our solution to constant space. Another way to solve this problem is by breaking this input down into two partitions and then solving them separately. And before we do that, we need to reverse this input array. This is my reversed array and this is the expected output. If we compare the two arrays, we'll notice some patterns. Starting with the first two characters or first k characters, the elements in the first array are exactly in the reverse order in the second one, that is the expected output array. While the same can be said for the remaining elements, that is 3 to 1 is in the reversed order or reversed output, while in the rotated array it is 1 to 3. So the pattern here is we need to use the value of k, draw a partition on the reversed array and then individually solve the smaller partitions. We'll take the first partition, reverse it and then save it or make it as our expected rotated array and do the same operation with the second partition. Please note that the partition is done based on the value of k. Because the value of k is 2 here, we are taking the first two elements and then drawing this partition. After applying this operation, I will get this expected output. With this solution, my time complexity is O of n, where n is the size of the input array, and the space complexity is O of 1, that is constant space, because we are not maintaining any additional collection. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by validating the inputs given to us, that is the size of the nums array and the value of k. I am then applying the mod operation on k based on the size of the input array. Following that, I am reversing the array so that we can build those partitions. I have an helper method created which helps me sort an array based on the start and the end index. It only uses this one temporary variable as we are reversing the order of the array. This helper method is being called twice, one for each partition. Once this operation is complete, the updated or rotated array will be saved in this nums variable. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime, 97% in terms of memory. Thank you for watching this video. I hope you were able to understand this explanation. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.